folks, and welcome to another episode of Mears Lab. Today we're going to have a look at this Anton Bauer battery that is not working correctly. So, what is this anyways? It's a battery pack that's typically used in film cameras, video cameras, and the reason why they use this is because it has a lot of capacity, and the benefit being that they can run the camera, they can operate it for a long period of time between battery changes, and that's a very, very good thing. Sometimes film shoots last a long time. So all of these squares on here are 1 inch square, so if we put that down there, we can see that this is approximately 3 inches long, 2.5 inches high, and maybe 1.5 inches wide. So a lot of capacity in a small space. How much capacity does it have? Well, here it is, 7.2 volts, 6,600 milliamps. And so this is an NP-F976. That's the model number. It's a lithium-ion battery pack, and it's got a couple of terminals right over there on the end of it. So anyways, what's the issue? It looks fine, right? The case is broken on this one. You can see it actually opens up just like that. And I think that the way that it happened was when this was removed from the device that it was plugged into. Because the way that that works is you kind of, if this was the device over here, then you would put the battery pack on the device and then you would slide it in like that. And then there's some clips that kind of fit inside there and on the other side too. So either it hadn't come out all the way to clear the clips, and then someone tried to pull on it and it just lifted the top case off, or maybe it just kind of fell or something and hit, and then it just kind of like hit like that. Anyways, the problem is it's not just a plastic case. That'd be pretty easy to fix. You just wrap tape around it or glue it or whatever. The problem is, okay, we'll just remove that. We don't need that anymore. The problem is where the connections are right here and here are supposed to connect to these points right here on this little circuit board. And there's little solder tabs that are broken in the middle right there. So we'll have to resolder those. And then it should work fine. It should be a relatively straightforward repair, this one. Anyways, so without further ado, let's move ahead and let's get right into it. I always like to try and come up with a plan first before I proceed, and that way I have a direction. And the method I use for this is called the next step method. So what that means is I'm always thinking, once I've completed something, what is the next step? And the idea being I have a goal, and there's a couple of different steps we have to take to achieve that goal, right? So we just need to identify what the steps are and then just take one right after the other, and eventually we'll get to our goal. So our goal is, well, to get the battery working, of course. And the issue is that these two tabs are broken right here, which are the positive and the negative connections. So we have to repair those. Now, the concern is that if this is very fragile, and if we pull on this too much, that it could damage this other last remaining terminal right here, or perhaps the other terminals in the batteries. So we have to be very careful how we approach this. And it's not going to take too much work. It's just having the right equipment and being very careful how we do it. So what we're going to do is I lifted this up a little bit to have a look already. So let's do that again, just very carefully, because this right here is still attached and we don't want to break that one off. So we can lift that off very carefully and we can kind of see what's going on. So right in here, you can kind of see there's the tab and there's the solder pad right there. This is the tool we're going to use to remove the solder. This is a Heiko FR301. Pull this trigger, tip heats up, and it removes the solder through the tip. So here we go. And just like that, it's done. So the old bead is on there still, so we'll have to remove that. And we'll just that there. we'll just use our soldering iron and see if we can just kind of move it right off there. Oh, there we go. Now that I've had a closer look at this, I kind of feel like these tabs actually aren't long enough to reach the pads. So what I'm going to do is I'm going to remove the solder from this pad right here, and so I can remove this top plate. Then I'm going to extend these leads. I'm just going to use short little wires to do that. There we go. Now it's a little easier to see on the inside. There's the tabs in question right there. There's another one down there, and there's the one that's still in good condition. Got these little protectors right here to just protect any kind of short circuits from the inside of it. Here's the little circuit board. Everything's fine on there. Next, we're going to remove these little green covers right here. It's just like kind of like a sticky piece of tape is all it is. Not sure what its electrical insulating properties are like, but whatever. That's what they used. I'll put it back. So there's the inside now. I've got these two little wires cut now, and what I've used for that is these two spools of wire, black and red, and this is basically just solid core 22 gauge wire. So we've got to be really careful when we're soldering to these these tabs here, because well, there's plastic grips on them and we don't want to melt the plastic. That would not be very good. Okay, that one's good now too. All right, that worked wicked. So now I can take the battery leads here and I can just kind of put a U shape in them and then bend them around so that they reach those tabs. Hold it down with a piece of wood, and then we're going to clamp the piece of wood down. That way my clamp doesn't melt. Tab gets held down, and everything's awesome. That worked pretty good. It's clamped down pretty well there now. Look, there we go. Now we can check to make sure that there's continuity on everything. Here we go, this is on the continuity test. That's what we want to see right there. Now we're going to test this one. All right, look at that. That's what we want. And now we'll do this one. Excellent. Okay, battery's fixed. Looks great. Everything should fit back together pretty well without any trouble. And we just need to seal it all back up now. So let's just have a little bit of a fit here and see how well it does fit. Yeah, it looks like it's all going to go back together really easily. That's great news. There's a little bit of room at the top of the case. I think I might just put some double-sided tape along here. That'll help to keep the top of the case on. If I'm going to do that, I can take this foam off of there to make a bit more room. We don't need that. Just take that, run that along there, like so. Be very careful we don't pierce the batteries. Can't remember which way battery cover went on. Whatever. I'm sure this will be fine. There we go. So it's all back together. There we go. Now the battery works. Repaired. Fixed. I got a bit of a mess going on here at the moment, but I have completed the repair of the Anton Bauer battery. And here's what it looks like. what I ended up doing was just getting some black duct tape and wrapping that around, then using a sharp knife and a ruler, which is no longer out, I was able to make some really nice clean cuts all the way around to provide some support. It has the double-sided piece of tape in the top of it as well, holding the cells to the inside of the cover. So the reason I went with the tape here is I needed to hold these two pieces of the case together really nice and firmly. And I could have just used glue, but then I never would be able to open up the case again. Moment of truth here, folks. Where's the positives over here? Okay. Here we go. Ta-da! 7.8 volts. It's a 7.2 volt battery, so that's perfectly fine, and it means that it's fully charged right now too. So that's great. So that concludes the repair of the Anton Bauer battery. I'd like to thank y'all for tuning in. Please do like, share, subscribe, all that kind of good stuff, and we'll see you next time here on Mears Lab. Thank you. Have a good one.